Alright, we're going to take a look at our fourth type of chemical reaction here, and this is double replacement, and sometimes it's called ion exchange. And in a double replacement reaction, you're going to have two compounds, and in these two compounds you're going to have the negative ions switching place with each other, or the positive ions switching place with each other, and so you're going to get two different compounds on your product side. It is also called ion exchange since you have, again, the positive ions switching places or negative ions switching places, depending on how you look at it. And this is normally going to take place in a solution, so we're going to see a lot of AQ for aqueous. And you're going to get one of three products. You're going to get a precipitate, which is a solid that forms when the two liquids come together. You're going to get a gas, or sometimes water is created. So those are the three most common products. So let's take a look. We said that one of those things has to happen. So here we have a product that is slightly soluble, meaning that it won't dissolve in water. There are products that won't dissolve in water, and so they stay in their solid form, and they precipitate, meaning that they form the solid and they'll sink to the bottom because it's heavier than the liquid. And so we have that here. We have two aqueous solutions that when they have come together, we end up having cadmium sulfide, and that is a solid. It won't dissolve in water, whereas the sodium nitrate will, so that stays as aqueous. So sometimes we get solids. There are times where gases are produced. In this case, when the sodium and the hydrogen switch places, you get hydrogen cyanide, okay, and that is a gas. We could also use its acid name and call it the hydrocyanic acid, but it's a gas at room temperature. Or we could get water. And so here, when calcium and hydrogen trade places, we get H with OH, which is water. So we can get liquid water forming in some instances as well. So we're going to do some examples, and we're going to be in the first few is just going to tell you what the product is, and then we're going to take a look at a few that they don't tell us what the product is and see if we can figure that out. So we have calcium bromide and we have silver nitrate, and it tells us here that we're going to get a precipitate. So that's a solid. A precipitate's going to be a solid form, and silver bromide is the solid. That means that the other compound that we make is going to stay dissolved in water, so we're going to keep it as aqueous. Now, when you have a double displacement, double replacement, you're going to have your, in this case, calcium kind of switching places with silver, but it doesn't send silver to be a single element by itself. Silver is actually going to take the place of the calcium, and we're going to get two new compounds. So it told us that the silver bromide was our precipitate. So we're going to start with silver bromide. Silver is a +1 charge, bromine is a -1 charge. So we have silver bromide, and we're going to keep the S behind it for solid. And then that means that our calcium and our nitrate, and calcium, we need to remember charges, is a +2, nitrate is a -1. So we need to balance that by having two nitrates. That one's going to stay aqueous, or stay dissolved in water, and now our job is to balance our chemical reaction. So we have calcium here and one calcium here, so those are actually balanced already. We have two bromines on our product side, or sorry, reactant side, but only one on our product. So we're going to want to put a 2 out in front there, and that takes care of the bromine. Now we have silver. Silver, there was only one on the reactant side. There's two because of the 2 out in front of the silver bromide. There are 2 there. So we're going to want to put a 2 in front of the silver nitrate. That takes care of silver. And then NO3 we can keep as one polyatomic ion, but there's 2 NO3s. And if we take a look at our product side, we have NO3 in parentheses with a 2 behind it. So there are 2 NO3s on the product side already. So this one is balanced by adding in those 2's. Now if we do another practice problem, this one again is also telling us what we have. Forming a gas is one of the 3 possible products, and this one tells us that hydrogen sulfide is the gas that's going to be formed. So again, it's double displacement or double replacement, and so the iron and the hydrogen are each going to trade places to form two new compounds. So we have hydrogen with a +1, sulfur is a -2. So we need to have H2S for hydrogen sulfide gas, and we're going to put the G for gas. We also then are going to have the iron with the chlorine. Now earlier in the picture it mentioned that the ions don't change their charges, so in this case whatever charge iron has when it's with sulfur has to be the same charge that iron has when it's going to now be with chlorine, and that has to be a +2. Sulfur's a -2, iron has to be a +2 for these to balance, and you get one of each element. So when iron is a +2 with a chlorine which is a -1, we're going to end up with FeCl2, and that one's going to stay aqueous or stay dissolved in the water, and now we just need to balance out each of our elements on both sides here. So iron, 1 on the reactants, 1 on the product, so that one's already balanced. We have sulfur, 1 of those on both sides, so they're already balanced. We have hydrogen though, only 1 here on the reactants. We have 2 on the product, so we are going to need to put a 2 out in front of our HCl, and that will take care of the hydrogens, now 2 on each side. And chlorine, there are 2 chlorines and 2 chlorines here with the FeCl2. Again, writing your formulas, making sure that you have them written correctly is incredibly important. If you just would have put FCl, then you would have had to put a 2 out in front, you would have had to fix the irons, you would have been going back and forth trying to balance this, all because you wrote the formula incorrectly. But by writing the formula correctly from the beginning, it really saves a lot of time when you're trying to balance these. Alright, now in this case it doesn't tell us anymore what the product is, so we'll see if we can't figure it out as we do this. So again, we are going to exchange the positive pieces. So our K is going to be with PO4, we're going to get potassium phosphate, and H is going to go with our hydroxide. So we know that when we have H with OH, we end up getting water. So water is one of our products, and we know water is a liquid, so we'll put L. And then we also get potassium, which potassium's a +1 and phosphate's a -3, so we have to have K3 PO4 in order for our charges to balance each other. So now we need to balance our equation and make sure that the atoms on each side are balanced, because right now they are not. So if we start with the potassium, we have 1 potassium here on the reactant side, but 3 on the product side. So we're going to want to put a 3 out in front of the KOH. Now I left this as HOH down here because sometimes that might be more helpful in trying to balance our equation. So in this case you have 3 OH groups. We can keep this as a hydroxide ion. So we have 3 hydroxides, and if you take a look at this OH here, we only have 1, as just water, H2O, is a hydrogen, 1 hydrogen with 1 OH group. So if we put a 3 out in front of our water, a 3 in front of HOH, we have 3 OH, 3 hydroxide groups. So that takes care of the OH. Now if we take a look at the 3 here in the H3PO4, remember that by putting the 3 out in front of the water, this 3 HOH, you have 3 H's here and 3 of the OH groups. So that 3 in front of the water actually balances the hydrogens as well as the hydroxide ion. And PO4, there's just one of them on each side. So they're balanced. Now if you don't want to keep it as OH separate from the hydrogen, you can think of it as 3 times 2, so you have a total of 6 hydrogens here. 6 hydrogens, and you have a total of 3 oxygens. And if you take a look on this side, you end up with 3 H's from the KOH and 3 H's here. So you have the 6 hydrogens and the 3 O's from the hydroxide. So it does work out, it does balance. It just depends on whether you want to keep each and every element separate, or do you want to try and group them by their polyatomic ion. Last practice problem, we're going to go through again and redistribute our positives to form new compounds. And so we're going to have H with OH again, and I'm just going to write it as HOH for now. And then we have aluminum, by the way, we know that's water, so that's going to be a liquid. And then we have aluminum going with sulfate. Now aluminum is a +3 charge, and sulfate, SO4, is a -2. So when we're balancing out our charges, we need 2 of our aluminums, and we're going to have to put SO4 in parentheses and have 3 of those, and that one's going to be the one that stays aqueous just because we already have our liquid product. So now we need to balance this, okay, and balancing this one is going to involve first of all starting with, let's say, aluminum. There's 2 of those on our product side, but only 1 on the reactants. So we're going to want to put a 2 out in front there, and that takes care of aluminum. And if we take care of our SO4, since that's a polyatomic ion that is held together and it stays together, we have 3 of those. That means that we're going to need 3 SO4s on the reactant side to balance those out. And then we need to take care of our water. How many waters do we need? Again, if you think of it as HOH, you are thinking of OH right here. How many total of those do we have? We have 3 in every aluminum hydroxide compound, and we have 2 aluminum hydroxide compounds. So we have a total of 6 OH groups over here on our reactant side, which means on our product side we also need to have 6 OH groups. And if we take a look at the hydrogen here that was by itself, there are now 6 of those. 3 times 2 makes 6 here with the H2SO4. So everything is balanced in this equation as well. So just a quick recap of double replacement. You are going to create 2 new compounds, and you're going to do that by the exchanging of your cation ions. So the positives are going to be trading places with each other, so we do get 2 different compounds, and your products are going to be one of 3 things, either a precipitate, which is a solid, a gas, or we could have liquid water.